Hey there, this is video F24. It might be slightly different than the one in your booklet. There was a mistake. The original one is actually solving for P, not for I. So I'm hoping that I printed this off and gave it to you. If not, if you're looking at your book at F24, you probably want to check F22.5 as an answer key. Anyway, look around, you'll find it, you're clever. All right, Skippy invested $200 and it grew to $550 in 12 years, compounding quarterly. What interest rate did he earn? Okay, so this is compound interest. I'm circling that because I'm doing these out of order and I got to take a moment and think, okay, which one of our formulas? So this is the nice one. This is 8PIN. Excuse me. All right, so we start with $200, we go to 500, and it's 12 years, and it compounds quarterly. So N, whoopsies, is 12 years times 4 is equal to 48. My interest, see, it's looking, so I don't know what my interest is, but you know what? I'm going to do this. Just to remind myself, because when I get down here, the answer to this calculation would be what goes there. So when I want to go loop back to here, so to get it per year and into percent, I've got to multiply to get there. You don't have to do that. I just do that because otherwise I'm going to forget. And I have two amounts. So he invested $200 and it grew to $550. And a quick way to check is always remember that A is the bigger of the two. So we're good to go. Good to go. A is equal to P. Whoopsies, no, wrong one. 1 plus I to the N. So 550 is equal to P, which is 200. 1 plus, oops, I don't know the interest, to 48. All right, we want to get this by itself. This 48 is affecting that. But the quickest thing we can do is we can get rid of this. So we're going to divide by 200. Divide by 200. All right, 2.75 is equal to 1 plus I to 48. All right, now to get rid of the exponent, it's not divide because this is an exponent, remember? We're going to put big square brackets and we're going to make a new exponent and it's going to be 1 over that. And whatever we do to this side, we have to do exactly the same thing to this side, 1 over 48. So when that happens, this stuff disappears. That's the point of using this reciprocal, right? 1 over, that's the word reciprocal. It gets rid of the bracket, gets rid of our exponents. We're going to get 1 plus I. So on this side, the easiest way to do this, all right, so I already got 2.75 in there. I'm going to use my exponent key, and then I'm going to go bracket, because almost everybody's calculators, even the cheap dollar store ones, have that on it. 1 divided by 48. I'm going to close my brackets, and then I'm going to hit equals. 1.02129. I'm just going to dot. Okay. When I finish this question, I'll do that again, and I'll show you like an alternate, but that's the easiest way to do it. So now I'm going to subtract 1, right? Minus 1 here, minus 1 here. So I is equal to 0.0212 ... But you got 4.5 out of 5 on this question already. Remember, this is the interest as a decimal and per quarter. We have to adjust to get back into percent and per year. So we are going to multiply by 4 And we're going to multiply by 100. And notice I didn't even bother clearing it off. So times 4 times 100. And yes, you could just multiply by 400. All right, it gives me 8.5%. And there we go. Okay, so I was going to put a little arrow this over here. So 2.75. And then you take your caret key and then bracket 1, divide by 48, and equals. That's the keystroke you could use to do that. If you want, another option is just go 1, divide by 48. Ooh, I was hoping that wouldn't be a big long decimal. You could just write that down and go 2.75 and then caret or exponent 0.0208 through repeating. Either one of those is cool. Whatever makes more sense to you. Either way, you're going to get the same answer as me, and you'll get 8. Oh, I'm going to clarify. With this repeating decimal, just punch in a whole bunch of 3s. At least 1, 2, 3, 4, 5. If you get bored, punch in 10 because it's a repeating decimal. So this isn't the exact answer, but it's close enough. If you just put in 0.2083 and that's it, your answer might be slightly different than mine. Okay, let's do it again. I think, oops, or as always, I encourage you to turn off the video, try it yourself, and then turn it back on. All right, Bob deposited $4,500 in a GIC, guaranteed investment certificate, in 35 years. It had grown to, ooh, look at that, $25,000. What yearly interest rate was required for this growth if the account was compounded monthly and actually in reality, and the interest rate stayed the same? Usually interest rates on most stuff, GICs, I think Canadian saving bonds, things like that, they do tend to vary. Anyway, I'm not going to get too much into that because I don't have that much financial knowledge. I know how to do this, but I don't know too much about investments. APIN. All right, we have, this is what we start, whoops. Oh, that's showing up okay. 35 years, it's grown, and it compounded monthly. So N is 35 years times 12. I don't know what that is. I'll get over 35 times 12. 2,800. Not even close. 420. Okay. So I'm going to do it like I did up here. I don't know, but whatever it is, I'm going to divide by 100. I'm going to divide by 4. No, not 4. 12. Remember, matchy-matchy. Matchy-matchy here, matchy-matchy there. And that's how I remember and how I catch myself if I screw up. All right, A is the amount I start with. Sorry, no. A is the amount I end up with, which is 25,000 and 4,500. Okay, here we go. A is equal to P1 plus I N. 25,000 equal to 4,500. 1 plus I to 420. That's a lot of compounding periods. Divide by 4,500. 25,000 divided by 4,500. Oh my. 5.5. I'm just gonna do that. Right? So we got P, even though it ends in a 6, that's just the calculator doing the rounding. Is equal to that disappears. 1 plus I to the 420. Okay, even though it feels weird, 1 over 420. Don't overthink it. It's just 1 over whatever that number is. So we're going to take this, 1 over 420, and I'm going to leave this in my calculator. I'm going to press my exponent button, right? Gives me a little caret, and then bracket 1 divided by 420. Close my bracket. Boom. There we go. 1.00409 is equal to 1 plus I. And that makes that stuff cancel out. Subtract 1, subtract 1, subtract 1. 0.00409 and some more is equal to I. But just like before, we need to make the adjustment. That's per time period as a decimal. So we're going to multiply by 12. That'll give me per years, and multiply by 100 to convert it back to the percent we're using it to. So times 12 times 100. All right. So 4.9% is equal to I. And I've said it a lot of times since I didn't tell you how to round it. If you rounded that to 5%, I'd say sure. I picked 4.9 because it looked nice. There's nothing more profound than that. It was just a 0 there, and I thought, yeah, that's good enough. Okay, ta-da! One more, guys. One more on this page. All right. Lynn invested $4,700. After 8 years, the investment was worth $9,400. What was the yearly interest rate if it compounded semi-annually? So, A, E, I, N. There 8 years and semi-annually. All right, so 8 years. Semi-annually times 2 is equal to 16. My interest. Yeah, I'm trying to be cool and at least sort of look up so you guys aren't just seeing the top of my head, but it just makes life difficult. So sorry, you see the top of my head. Matchy matchy. Make sure I'm good. My principal is 4,700 and it is 9,400. Remember, so that's what we started with. That was the end point, and A is always bigger than P. So 9,400 is equal to 4,700. 1 plus I to the 16. Let's get rid of the 4,700. 9,400 divided by 4,700. Oh, it's 2. Well, that was nice. Let's make life easy. 1 plus I to the 16th power. Now let's get rid of that exponent. Oh, excuse me. So all of this is going to disappear. I'm going to get 1 plus I. And now I go 2 and an exponent in bracket. 1 divided by 16. Close my brackets. Boom. 1.044. There's some more numbers there. I'm going to subtract 1, just like I do on my calculator, minus 1. So 0.0442 numbers is equal to I. I'm not going to worry. Again, leaving them on my calculator. And I need to worry about my adjustment. So I'm going to multiply that by 2, and I'm going to multiply that by 100. So times 2 times 100. All right, that's going to give me 8.8 I don't know. What do you think we should round that to? Oh, sorry. I see ran out of room there. 8.9%? 9%? I don't know. I forgot to tell you guys how to round it, so I'm pretty sure I'll accept this one, or this one, or this one. When I was in university, what I used to do is I'd always write more decimal place than I thought, and then I'd round it up where I thought was appropriate. I made it through. I got my degree. All right. That's it for now. That's the end of that.